this is an anode. Why? Because in the electric circuit, it is connected to the positive terminal. And this is the cathode, since it is connected to the negatively charged terminal.
Why settle for ordinary lessons? Discover a smarter, easier way to learn. This is Muto Online. Get instant access to notes, past papers, and scenario-solved lessons, all tailored for competence-based curriculum.
Whether it's UNEB prep or just extra practice, we're here to make learning fun and easy. Subscribe now and let's ace those exams together.
Hello everyone, Teacher Alan once again representing Muto Online. I'm back once again to continue with our topic, and that is actually a subtopic, that is electrolysis. In the previous two videos we introduced the topic. In the first one, we gave the key terms. In the second video, we talked of the decomposition of different electrolytes. We gave the concept very well. If you followed that video, you can witness. In this video, I'm back strictly to take you through the concept of discharge of ions. So we are going to consider discharge of ions. So we are going to look at the discharge of ions. As you hear the word discharge, I don't want this term to be new to you. The word discharge, remember in the previous topic, in the previous video, we looked at how the ions are formed. And we are now going to look at how these formed ions, as a result of an electric current passing through a molten or aqueous form of an electrolyte, can be turned back to respective atoms, neutrally charged atoms, or group of atoms, the radicals. So the discharge is going to be either, it's going to involve gaining or losing of electrons by respective ions so as to form respective atoms or group of atoms. The word dis, removal of charge, it's what we are going to look at. So the removal of charge will involve gain, of electrons by ions purposely to form neutrally charged atoms or radicals. Actually, atoms or molecules. Remember, this process of discharge is going to occur only when the formed ions migrate to the to the opposite, the charged electrons. Let us assume we have an electrolytic cell with two electrodes. The electrodes connected to an electric circuit, and the electrodes are partially immersed in, let's say, an electrolyte that is either molten or aqueous. Let us take one that is molten. Let us assume in this electrolyte we have uh, two charged, two positively charged ions, A and B, and two negatively charged ions, C and D. We are going to look at the discharge process, which we've called the loss of electrons or gaining of electrons by ions in an electrolyte so as to form neutrally charged atoms or molecules. So, these electrons, these ions, before they are discharged, before they lose or gain electrons, they will automatically travel to oppositely charged electrodes. So this is a positive terminal connected to this electrode A. Let's call it electrode X, and this is electrode Y. So this electrode Y, X, is a positively charged one, meaning that this is an anode. Why? Because in the electric circuit, it is connected to the positive terminal. And this is the cathode, since it is connected to the negatively charged terminal. And remember, after ionizing or decomposition of an electrolyte, it will give two categories of ions: the cations, which are positively charged, and the anions, which are negatively charged. These ions migrate to oppositely charged electrodes after being formed. So the negatively charged ions will migrate to the positively charged electrode, and the positively charged ions or the cations will migrate to the cathode. Once they are at the cathode, one of the two will be discharged, will either lose or gain electrons such that it forms a neutrally charged atom or molecule. So here, the A and B being positively charged ions in the electrolyte will migrate to the cathode, and the C and D being negatively charged will migrate to the anode. One of these ones will be discharged from here to form respective atoms of either C or D, respectively, and then the B here, one of these ones will be discharged based on the factors we are going to look at. Members, for this electrolyte to form these ions, let's assume the A, B, C, and D, will only be possible if, let's say, if we had a switch here, will be possible if this switch is closed. If this switch is closed, the circuit is complete. It will create a charge or a current that will pass through this electrolyte, making it to decompose like we saw previously in the previous video. So the ions will only be formed after an electric current passes through the molten or aqueous form of an electrolyte. And once the ions are formed in the decomposition process, the ions migrate to oppositely charged electrodes, where one of them is discharged in preference of the other. And we've said that discharge will involve either gaining or losing of electrons by any respective ion. And once the ion loses electrons or gain them, it will become either an atom or molecule of that respective element. Members, the positively charged ions let's say the A, means that to form this ion, this atom of element A lost electrons. So for it to reform the respective atom, it must regain the lost electrons such that it can become the other element, the other atom of the other element. And simply, this is also known as reduction. So the positively charged ions will be reduced to their respective atoms or molecules. And then the ones that are negatively charged, let's take an example, the C, negative. It means that to form this one gained an electron. So for it to become the respective atom or molecule, it has to lose the gained electrons. That's why there is a negative. On it, there is a negative, there is a debt of an electron it gained. So it will need to lose electrons so as to form the respective atom or molecule. You can alternatively write like that or like this. So the positively charged ions in an electrolytic cell will be discharged by gaining of electrons. The atom previously lost, and the negatively charged ion will be discharged by loss of electrons. To repeat for you, for one to write an atom like this, it means this atom of this element A became this after losing an electron. So for you to reform this, it means you must add this number of, that's why there is a plus sign here, that you must add the other lost number of electrons, here it is 1, to reform the previous atom or molecule. So the positively charged ions will be discharged by gaining of electrons, and this will be at the cathode, because we said the positively charged ions migrate to the cathode, and the negatively charged ions migrate to the anode. They migrate, in short, they migrate to oppositely charged ions, electrodes. So this, for the negatively charged ones, they will be discharged by loss of electrons. So here, the C will be oxidized to this, to the atom of C. The ion of A will be reduced to atom of A. Remember, oil leak. Oxidation is loss of electrons. Reduction is gain of electrons. You remember that abbreviation in the previous videos. To continue, I think we all know this. There are factors that determine the prevalence of discharge of these ions. Because we previously saw that if the electrolyte is copper 2 sulfate solution, this is a solution in aqueous state. It means being in aqueous, it means this copper 2 sulfate solute was dissolved in water. This means in this electrolyte, there is both water and copper 2 sulfate. In the previous video, we saw that the water undergoes partial ionization to give hydrogen ions and the hydroxide ions. And then the copper sulfate, being a strong electrolyte, will undergo complete ionization to give copper 2 ions and sulfate ions. So here it means in the copper 2 sulfate electrolyte, if it is used as an electrolyte in an electrolytic cell, it means we have 2 cations. We have hydrogen and copper as our cations. We also have the hydroxide ions and the sulfate ions as our anions. We are going to find that the hydrogen and copper will migrate to the cathode. Why? Because these two are positively charged, so they will go to the negatively charged electrode. And once there, one of these ones will be discharged by gaining of electrons or by reduction. And the two negatively charged ions, the hydroxide and the sulfate ions, will migrate to the positively charged ion, which is the anode. And once there, one of these two, not all, but one of these two will be discharged in preference of the other by oxidation or loss of what? Electrons. Note it very well that the negatively charged ions go to the anode. If you have your neighbor, you can tell it to him or her. The negatively charged ions migrate to the anode. And once there, one of them will be discharged. And we've said that the discharge of negatively charged electrons is loss of electrons. One of them will lose electrons or will be oxidized. And an oxidation of an ion or an ion at the anode will result in formation of the respective atom or what? Molecule of that respective element. And then the cations will migrate to the cathode. The positively charged ions will migrate to the positively charged electrode, to the negatively charged electrode, which is the cathode. Once at the cathode, it will gain, one of them will be discharged by gaining of electrons or by reduction to form respective atom or molecule of that element. Not both, one of them. And the choice or the preference of the discharge depend on the following factors. So we have what we call the preference. The preference of discharge of ions and electrons. We are going to see which of the ions will be discharged in preference of the other and why. So as we get to that point, I request we take this into the next video. We come back with those factors that determines the preference. If they go, two of them, hydrogen and copper, which one of them will be discharged? Why? What will be the product at that given cathode? Remember, we are Muto Online. I'm Teacher Alan. Don't forget to subscribe, to invite friends. Don't miss the next video when we are looking at the factors that determine the prevalence of discharge of ions at electrodes in electrolytic cells. So now,